Have you ever looked up at the night sky and wondered how big the universe really is? Not just in a casual way, but really sat there and asked yourself, does it go on forever? Does it have an edge? And if it does, what could possibly lie beyond it? These questions are not new. They've been asked for thousands of years. Ancient civilizations looked at the stars and built myths about gods living in the heavens. Philosophers imagined invisible spheres carrying planets and stars around the earth. And today, scientists with advanced telescopes and powerful equations are still asking the same basic questions. We all feel it when we look up. The night sky sparks curiosity. The sheer scale of what we're seeing makes us wonder, where does it all end? Let's take this journey step by step and see what modern science can tell us about the edge of the universe. 13.8 billion years ago, everything we know began with what we call the Big Bang. Now don't imagine fireworks exploding into empty space. The Big Bang wasn't like that at all. It was space itself beginning to expand. There was no outside waiting to be filled. There was no ticking clock, no cosmic canvas. As strange as it sounds, time and space themselves came into existence at that moment. Physicists often explain it this way, asking, what happened before the Big Bang is like asking, what's north of the North Pole? It's not a question with a meaningful answer, because before didn't exist in the way we think of it. From that moment, time began to flow forward, space began to stretch outward, energy appeared, condensed into matter, and from there, the building blocks of stars, galaxies, and eventually life itself were formed. Right after the Big Bang, the universe experienced something extraordinary: inflation. For a tiny fraction of a second, the fabric of space itself expanded at a rate faster than the speed of light. That might sound like it breaks Einstein's famous rule that nothing can move faster than light, but Einstein's rule applies to objects moving through space. Inflation was space itself stretching. There's no law that says the fabric of the universe can't expand that quickly. Imagine you're standing on a giant rubber sheet. At first it's flat and still. Suddenly the sheet stretches out in every direction, faster than you can even comprehend. You don't move, but everything around you races away. That's what inflation was like. Scientists believe this inflationary period smoothed out the universe, spreading matter evenly and solving puzzles about why the cosmos looks so uniform today. To make sense of this cosmic expansion, we use analogies. Picture a balloon with dots drawn on its surface. As you blow air into the balloon, the dots move farther apart. None of the dots are crawling across the surface. It's the balloon itself expanding. Or think of raisins in bread dough. As the dough rises, the raisins drift apart. In the same way, galaxies are carried apart because space itself is stretching between them. But remember, these are just analogies. Real space is more complex. Gravity holds some structures together. Our Milky Way galaxy and the Andromeda galaxy are actually on a collision course. They're moving closer, not farther apart, because their mutual gravity overcomes the cosmic expansion. So while the balloon and dough examples are helpful, they're not the full story. Now here's where things become even more surprising. The universe isn't just expanding, it's expanding faster and faster. In 1998, astronomers discovered this by observing distant supernovae. They expected to find the expansion slowing down under the pull of gravity. Instead, they found the opposite. The expansion was accelerating. Something was pushing the universe apart more strongly than gravity could pull it together. That something is what we now call dark energy. It makes up about 70% of the universe, yet we don't know what it is. It doesn't shine. It doesn't clump. It doesn't behave like any form of energy we've studied before. But we see its effect in the way galaxies accelerate away from us, and in the pattern of ancient light called the cosmic microwave background. It's as if there's an invisible pressure built into the fabric of space, pushing everything apart. So what does this mean for the future of the universe? Fast forward hundreds of billions of years. If dark energy keeps driving expansion, most galaxies will drift so far away their light will never reach us. The night sky, once full of stars and galaxies, will become dark and quiet. Only our local group of galaxies will remain, our Milky Way, the Andromeda Galaxy, and a few smaller companions. Everything else will be gone from sight, not because it no longer exists, but because the universe will have expanded so much that their light can no longer catch up to us. Picture standing in the middle of a glowing city, surrounded by thousands of lights. Now imagine those lights turning off one by one, until only a few remain in the distance. That's the cosmic future. Future astronomers may look up and believe the universe is small and static, never realizing how vast it once looked in our time. So how big is the part of the universe we can see today? The answer is surprising. You might think the limit is simply 13.8 billion light years, the age of the universe. But because space has been expanding the entire time, the farthest galaxies we can observe are actually about 46.5 billion light years away. That makes the observable universe about 93 billion light years across. Let's pause and let that sink in. 93 billion light years. A single light year is about 6 trillion miles. Multiply that by 93 billion, and you get a number so vast that it breaks our intuition. It's so large that our usual sense of distance, even when thinking about planets and stars, completely fails. Astronomers sometimes compare it to maps. Imagine trying to draw the entire Earth on a single sheet of paper. No matter how you fold or compress the continents, something gets distorted. Our minds evolved to understand forests, rivers, and mountains, not billions of light years. And yet, even with all that size, there's a hard truth. We will never reach the edge of the universe. Even if we could build a spaceship that traveled at the speed of light, we'd never catch it. The edge isn't a fixed boundary, it's a moving horizon. As space expands, the horizon keeps retreating faster than light itself. It's like running toward a finish line that keeps moving away faster than you can sprint. The race is unwinnable, so what lies beyond that horizon? Here's where science meets imagination. The most honest answer is, we don't know. The universe could be infinite, stretching without end, or it might be finite but curved, like the surface of a sphere. If you keep walking on Earth, eventually you return to where you started. Maybe the universe works that way on a much grander scale. Some scientists suggest an even more radical idea, the multiverse. Perhaps our universe is just one bubble in a vast cosmic foam. Each bubble could have different laws of physics, different kinds of stars, even different kinds of life. It's a thrilling possibility. But so far, it's speculation. We have no direct evidence. The mystery is humbling. Imagine a goldfish in a bowl. To the fish, the bowl is the entire universe. It can't see beyond the glass. It has no concept of what lies outside. We may be in the same situation. Our bowl is the observable universe, and whatever lies beyond remains forever hidden. And yet, isn't that part of the beauty? To live in a universe so vast that we may never know its true scale, to ask questions that may never have answers. It shows how small we are, but also how remarkable it is that we can ask these questions at all. Billions of years from now, when future astronomers look at the sky and see almost nothing, they may never realize the universe was once full of light and structure. But we, here and now, can still see it. We live at a privileged time, able to glimpse the cosmos before it slips beyond our horizon. So let's bring this together. The universe began with the Big Bang 13.8 billion years ago. It's been expanding ever since, and the expansion is accelerating. The observable universe spans about 93 billion light years across. We'll never reach its edge, and what lies beyond remains a mystery. That's why the edge of the universe isn't just a scientific puzzle. It's also a call to imagination. Is the universe infinite? Is it curved back on itself? Is our cosmos one bubble among many? Or is the truth something so strange we can't even picture it yet? We may never know, but asking the question, that's what makes us human. So what do you think lies beyond the universe we can see? Could it be endless? Could it be finite? Could it be something stranger still? Share your thoughts in the comments. And if you enjoyed this journey, don't forget to like and subscribe. There are more mysteries waiting out there, beyond what we can see. And this is just the beginning.